Well, hello, everyone. This particular session we are doing from 3 points around the world: Singapore, Australia, and Canada, technically, but actually in India at the current time. I'll introduce you to two of my colleagues in just a few moments. But this session, we really wanted to make all about education. No sales pitch, no spin, straight into the technical details. And I think this will appeal to both technical and non-technical audiences as well. We'll make it super informative and super informal. Let's have some fun with this. So without any further ado, I'd very much like to introduce you to the topic today, which is all about SSL bypass and SSL pinning. Why is this important to us? Why is it a major issue for mobile applications at the moment? And what do we need to do about it? And what solutions are out there to help us? Now, what's very interesting before we begin is normally we don't get to talk about our clients. Why? Our clients are discreet because we're finding things in our clients. However, Appdome is a client of ours and is very, very open about this and wants to do a really, really fine job of making sure that their tech is protecting things. So as our client, we are here today to actually discuss some of the work and the research technically that we've done, some pretty in-depth stuff of late around this subject to share with a wider community what it is we found, what the issues are, and what mitigations are out there as well. So let's look at the agenda very briefly. We'll introduce you to the subject. We'll look at various mobile vulnerabilities. We're just going to signpost Stride here for you, but I think that's one that really needs to be researched for you guys offline else time. Frida, and very importantly here, developer challenges, something we really, really want to call out on Avinash. I know that's a big subject close to your heart as well. And then looking at some mitigations. So without further ado, we've got two wonderful people. Jan Sysmans is Mobile App Defense Evangelist. I wish I had a title like that. That is super cool. Jan leads that within Appdome. And we've also got Avinash Thapa. Avinash is a VP of Technical Services in Chaleit as part of our global VP group, and a seriously interesting person who I've known for very many years as well. So let's get straight into this. So handing straight over, Avinash, tell us general and common mobile vulnerabilities. Where's your mind at? What happened when Jan said to you, hey, Avinash, I need you to rip this apart? And how do we come about looking at SSL pinning and SSL bypass?
Right. So basically, what happens whenever we test any mobile application, right? So some of the vulnerabilities which are very common, and you would find those vulnerabilities typically in most of the application that is present in App Store or in Google Play, or even though if they are actually directly provided by the clients to their customers. So these are the vulnerabilities like SSL pinning, root detection, sensitivity disclosure, and reverse engineering. All these vulnerabilities are very related to each other in terms of identification. And it says that, okay, if you are able to find one particular issue, you would be able to use that thing to, traverse and create a major impact in identifying other vulnerabilities. So let's just start with, some of the definitions and the impact of vulnerabilities such as SSL pinning. So in SSL pinning, what happens? So let's just talk about, first of all, what SSL pinning is all about, right? So it's actually a technique that's being used by mobile application to mitigate the risk of man-in-the-middle attacks, So what it does, it actually hard codes the certificates or its public key in an application, or in a, more layman terms, in APK file or any IPA file that you have for an Android device or any iOS device. So what happens now, SSL pinning is ensuring that whatever communication is going on from your client to the server is actually genuine communication. And the APIs which are trying to connect from your client to server, they are actually connecting to the genuine server, not someone, not a fraudulent one. When an attacker attempts to bypass this vulnerability, what they do, they try to intercept your communication, which actually goes between the mobile application and the server. And it could lead to, multiple issues like sensitive data exposure, like, session hijacking, and man-in-the-middle attacks, again, which is very, common, like checking what's the traffic going on from a client to server, what sort of requests are going on, if that request contains any sensitive data. For example, if there is a cart request, someone is trying to purchase a particular product, they might send their card numbers and someone is intercepting. So effectively, that's actually, letting the attacker capture those card numbers and stuff like that. So that's very, so these are the impact when it comes to, identifying and exploiting SSL pinning vulnerabilities. Yeah, let's move to the another one, root detection. Now, root detection is also, which is very, what you say, common vulnerability. You're going to find it mostly in all the applications, unless, it's being restricted from a compliance perspective. Like, for example, if any financial institution says that, okay, we don't want people to run application on compromised devices, then you're going to find this protection implemented on their applications. But generally what happens, root detections is commonly not available. So what it does here is the attacker has capability to install the application on a compromised devices. The moment they install that application on those compromised devices, they can effectively control everything about it. They can actually go ahead and tamper the behavior of the application. They could go ahead and tamper the execution of the application. They can see what sort of files these applications are creating and stuff like that, right? And so the mobile devices that we usually have, they are running on very low privileges, with very low privileges. So whenever the mobile application installs over there, they have its own sandbox environment. And that sandbox environment does not communicate with the other application, which are also installed on the same app, on the same device, right? But if the root detection is not implemented and attacker is able to install the application on a compromised device, effectively they can move around from those sandboxes from one to another to actually go ahead, to perform all sort of activities like exposing sensitive data, probably, again, the thing that I've said, that manipulating the application behavior. So these are the impacts when we talk about root detection. And after that, the another major issue that every application faces is sensitive data exposure. So what happens whenever we are logging into an application, we send username and password, it generates a session token, and based on session token, we can access, other functionalities of the application, right? So in order to make sure that user don't add credentials over and over, maybe sometime application, what they do, they put those credentials locally somewhere in the application, in the files, which are actually on the device. And they use those credentials from there so that there is a seamless transaction between the user and the applications, seamless experience. Now, if we see that if my application is vulnerable enough that it's installed on a rooted device or jailbroken device, now I have an opportunity to install another application on the same device, and try to see if I can, capture those data, those username password, which was, logged by a legitimate application, right? So now so that's a sensitive data. Sometimes they don't store username and password. What they do, they actually store session credentials, like session tokens. And sometimes, and there is another vulnerabilities when it comes to session, that they're not expired properly, stuff like that. If that also integrates with it, it actually has a major impact, because you can just capture one session and use a session to perform all sort of interaction with your application, right? So that's again a very common and I would say a severe issue whenever we are actually dealing with mobile applications. Now, reverse engineering is actually a source of everything. If my code is not obfuscated at all, I can actually see my code. I can just download the APK file. I have my IPF file. I can pass it through the disassembler or a debugger, where I can go ahead and see what's the logic looks like, what the code looks like. And based on that code, I would be able to see, okay, what sort of logics are implemented. Is there any root detection implemented in the application or not? If not, then it's actually very easy for me. If there is any protections are implemented, then how they are implemented, what sort of things that they are checking up for. Like, for example, if you see in this particular screenshot, the last block of the code, it says that, the application is trying to look for superuser.apk, the superuser.apk. So it means if it finds superuser.apk, it means the application is running on a rooted device. Then your legitimate application will say, no, you cannot run it on it because it's actually, your device is compromised. So if this is thing which is completely visible to the attacker, they will be able to see how to bypass that particular logic, so it will give them proper attack surface, proper room to go ahead and, try spend some time in order to find the bypasses of these sort of vulnerabilities. And it's a cat and mouse game, I would say,
So Avinash, Jan, one for you both. This is a nightmare, isn't it, for an application and mobile developer? There are so many hostilities in their environment, and they're not just trying to focus on the creation of an app that does good stuff, but so many methods of pinning this. Why are there so many challenges from your perspective for a developer here?
So yeah, challenges could be anything. So we can talk about those challenges, in the further section. But just to provide an overall idea, I would say skill set is one challenge. Secondly, time restriction, because obviously they have to go live and they have to create enough secure solution so that it's actually available to the market. That's actually one of the reason where we leave these small spots available in the application, which actually gives an attacker an opportunity to go and explore those things to find bypasses and stuff like that.
Yes.
Challenges could be anything, but these are the basic two challenges that I've seen in my experience with developers. Like, so why they are keep going on with the similar set, and there could be also one other reason that when you're creating a code, by default, providing a particular obfuscation, it's little difficult. For that you require special skills or use special tool sets. Maybe if it's not available with them, it would be very difficult for them to actually go ahead and provide the protections.
So we've got a skill issue here, and some life cycle. Jan, is this a balance between features and functions and security, and features and functions always win? What are your thoughts?
It's actually a very, very important question that you ask. Features and functions versus security. I'm going to answer it in a couple of ways, but one of the things that we do at Appdome, so we're a mobile app security company, we will actually protect the mobile app without developers having to do any work. But annually we do a survey. We do a survey to consumers around the world on their expectations of mobile app security. And what is extremely telling, okay, it turns out that for consumers, security is as important or more important than features. And I want to just say, from a consumer standpoint, they've told us in the survey that for the consumer, features are not the most important thing. Security is as important or more important than features. And I think that points to what you said earlier, and the question you asked earlier, Dan, is around the complexity. So and Avinash already alluded to that already. So iOS and Android are two completely different operating systems. You typically have an iOS developer, you typically have an Android developer. It's very difficult to find somebody who's an expert on both areas. So that's number one. Right. Number two is a mobile app can be developed in many different frameworks. Mobile app developers have lots of choices and the freedom to pick the framework and change the framework if they see fit, to pick the framework that best meets their goals. And what are mobile app developers' goal at? What are their KPIs? Their KPIs are around engagement. The KPIs are around time in the app. The KPIs are around downloads. The KPIs are around monetization of the app, but the KPIs are not around security. And so the developers are focused on building the best possible user experience using many different frameworks that they can build this on, both in Android as well as in iOS. Now, on top of that, and so Avinash, you've just gone over 4 or 5 different attack vectors, but there's many, many more attack vectors. And more recently, a lot more modern attack vectors that are being introduced. Recently, one of the big ones that is going out and that everybody's talking about is this notion of services accessibility malware. Malware that will escalate the services accessibility permissions on an Android device. And then once that is done, it then can launch its malware, and that malware can start attacking apps. None of the protections that Avinash talked about earlier in a couple slides actually protect against that. So it is actually extremely complicated for a developer or a set of developers who are focused on building amazing user experiences to then protect against all these different modern malware and tools out there. And so what Appdome can do, Appdome offers these developers a no-code solution to easily build the required protections in their mobile apps without them having to make any changes to the way that they build their apps, so without any disruption to their build process.
That makes absolute perfect sense. Just the skills, resource, time, depth of knowledge, series of challenges, I guess. And tell us, Jan, why did you ask us to look at this particular use case, SSL pinning? What were your thoughts around that? Why us? Why that pinning? And I mean that from more of a technical challenges perspective. Yeah,
absolutely. And Avinash, I'm going to put you a little bit on the spot here, but when we first met, you had said and told us, hey, Jan, I've never met an app that I cannot compromise with an SSL pinning bypass attack. And that kind of started to challenge you. Say, hey, great. We believe at Appdome that we can fully protect mobile apps against SSL pinning bypass attacks without coder coding, make it very easy. And so this is how the conversation started. But if you think back of what you said in the beginning, then this is truly an educational webinar where together, Appdome and Chaleit, what we're trying to do is educate the market on better ways to protect consumers and to protect mobile brands without having an impact on the development cycles. Developers today live in a very, very agile world. Developers today want to be able to release quickly, want to be able to release new features. The Christmas season is coming up, so there's going to be promotions in there if you have an e-commerce tool or you have some kind of transactions in your mobile app. You will want to be ready for that. And so a release cannot be held back because somebody says, hey, we found vulnerabilities. And I think you at Chaleit, one of the things that you see when you work with your customers is that you may identify vulnerabilities, but then the customer does not know what to do. They have no immediate idea on how to implement these services. And so the point of this educational webinar is to really show people that there is an alternative, that there is a way of, number one, these vulnerabilities are really serious, that can really have a negative impact to your app, but there is a way of being able to fully protect against those without causing disruption in the DevOps process. And that's really, from an educational standpoint, is what you said in the beginning. That I think is going to be the biggest takeaway from this webinar, is that, hey, there is a way for us to achieve the security outcome we're looking at without disrupting the DevOps processes that we've spent so much time building out and automating.
Well, on that note then, so Avinash, I think the content that's coming up now will start addressing some of Jan's points. Let's dive into the next part of what you wanted to share with everyone and then start answering those questions as we progress. Tell us about 100%. Frida.
Yeah, so Frida is actually not a thing that people don't know about. So it's one of the very most known tool set, or the toolkit for any information security researcher or any analyst. So if you are in security, definitely you know about Frida. If you are actually, or specifically if you are in a mobile security, and this is, I would say, one of the way which is very interactive, which actually helps researchers like our researchers, to test mobile applications, to find out the logics, to bypass those logic and stuff like that, right? Yep. So all these vulnerabilities that we discussed recently, like SSL pinning, root detection, and stuff like that, that can be exploited with the help of Freda, and there are other tool sets present under the toolkit of Freda to utilize to find the vulnerabilities. So now here, if you see the screenshot here, right? So it's trying to communicate with the binary which is installed on a device and trying to run a root and SSL bypass JavaScript. So this JavaScript was created by understanding the logic of that APK, and that logic was only understood because we, as an attacker, we were able to reverse engineer that particular application, because the code was not obfuscated, things were visible properly, so we could see the classes, we could see the functions, we could see the methods and everything, and with that thing we would be able to create this JavaScript which would help me to bypass this protection if there is any in the mobile application. So yeah, so Freda is all
then if I may actually add what Avinash just said. Avinash, what you just said is exactly how the bad guys work. Okay, right. And that is why when somebody comes and says, hey, I want to better protect my app and I just want to build obfuscation in my app, or I just want to build 1 or 2 levels of protections in my app, that is not going to be sufficient. And the reason why that is not going to be sufficient is just the thought process Avinash explained was, we're going to start with one attack. We're going to start with one understanding. And as we better understand how the logic of this app works, how the app communicates with the backend, et cetera, then we will write specific attack patterns, code, here in this case using Freda, but could be in other ways as well, so that we can take advantage of some of the vulnerabilities we've identified and launch our attacks. And so that's the other difficulty of mobile app protections or building a comprehensive defense, is that there is no single way that somebody goes out and always does the same thing. Attackers find ways of approaching the problem and finding a way to their resolution. And that is why at Appdome, at least, and the same for you, when you talk to your customers, you advise them to build a comprehensive protection model in their mobile apps, so that what Avinash just said cannot be done, which is do all of these little investigations to then specifically find the right tool or write the right scripts to achieve the outcome that somebody is looking for. So thank you for explaining that.
Absolutely. Well, let's lead into these, because I know this is your key passion here, Avinash. Developer challenges. Let's unpack some of these briefly.
Right. So we were already talking about these challenges, means when you were asking questions to Jan. So yeah, so from my experience, I've seen that there are lots of challenges being faced by developers when it comes to fixed vulnerabilities. So I tried my best to, put all those challenges in these 3 categories, like individual developer challenges, team challenges, and planning and implementation challenges. So if I'm, thinking of myself as a developer and I'm part of a particular team and someone gives me a list of vulnerabilities that I have to fix, the major challenge for me to understand the code base, first of all, because I don't want to mess the code base entirely just to fix a particular vulnerability, right? So that's the very biggest challenge for me. Secondly, balancing performance and security. I don't want to introduce too much of security in the application, which would impact the user experience completely. I don't want to do that at all. And also, for example, if I add lines of code, that would, delays the execution of the application. So that's also going to impact the user space, right? The customers. Testing and validation is another challenge that individual user faces. And they also have to keep up themselves with the security best practices all the time, because obviously it's like I said, fixing vulnerabilities like SSL pinning and root detection is not like one-time solution. It enhances, and if someone is very interested in mobile security, they would definitely spend their proper time to find a particular bypass, right? And now you have to keep up with that particular bypass to see how you can go ahead, and circumvent that thing. So that's the individual challenge developer faces. Now, when we come to the team challenges, a product owner receives a list of vulnerabilities that they have to fix. Now they have to find correct skill set, like Ken, you mentioned earlier, there are different frameworks that are being used to develop applications, right? Different platforms are there, different operating systems are there. They have different individual teams to perform all this activity. So yeah, diverse skill set is definitely one of the major challenges that people faces when it comes to fix any vulnerabilities and stuff like that. I would also, stress on the dependency here. So for an example, if company A has a product, but their dependency says, that they have a third party who's actually doing the development. Now they have to rely on their schedule to, go ahead and fix the vulnerabilities and stuff like that. So it's actually introduced a lots of challenges. But if I have a very tight deadline, then I would definitely rely on a platform like Appdome, where I don't need to do much. I just have a, packaged compiled binary. I just need to pass that binary through the product, just talk about the security models that I want to implement. Like for example, I just want to fix SSL pinning. I want to fix, Frida detection and stuff like that. And with just few clicks, I'm able to create a version of my application which is secure enough that can go to the public and things like that. What I really like about the platform, and it was actually very fascinating because I didn't understand it, when I was doing the testing. So whenever I create a secure version of the application, the classes which are being created for that secure version is always different. So it's not like that if I pass the same application multiple times, those classes will be same in all the new compiled binaries. So that randomness is really good, right? And that actually also helps developers. Like for an example, if I'm able to find a bypass, in any of the vulnerability after it being actually secured, I won't be able to run that bypass forever, So if it refreshes again, that bypass would be non-applicable, right? So these challenges, means the developer has and how they can be fixed. So this is actually a, interaction all about the collaborations, stuff like that. So if you want to, yep. So I think.
So Avinash, allow me to ask one follow-up question on this. So you described this for one release, but this is true for every subsequent release, isn't it?
Exactly.
Yeah. And so, so I'm going to piggyback on one other thing you said earlier is the company is under pressure to get the releases out.
Right.
But you just described the challenges the developers have with implementing the protections. So what do you think is going to win? The business needs for the company to get the new releases out, or the compliance with specific security and fixes in order to make sure that the app is as secure as possible? In reality, and what we've seen in real life, as it turns out, the business requirements always win. So what you get then is you get the developers and the business unit going up to management asking for an exception. Hey, we know we have vulnerabilities, but we need to release anyway. And that's the problem. And that's so you said earlier that a platform like Appdome allows you to do this in an automated way very quickly and immediately address all of the vulnerabilities that were found, rather than one of the things that you said as well is the hard choices. Well, we only have so much time to do some fixes, so we're only going to be taking what we believe are the most important vulnerabilities, 1, 2, and 3. And so you leave everything under there and you leave that out there. So that is, I thank you for going over this in such detail, because that is the reality we see with our customers. And when they come to us, that's the reality we see all the time. And I think, Dan, that's what you see as the reality with your customers as well.
I think what's very important as well is, we are not tied in our business model to any particular vendor, application, and so on and so forth. And therefore, hearing what Avinash said was, as an end security professional who is trying to bypass and get into these mobile apps. So I think that gives a level of authenticity, and it's very nice to be the other way around. We're not anything other than Appdome is our client. And that's lovely to then just get this open. So let's move on very briefly before we get into a little bit more technical detail. Jan, you are very keen on just discussing a few key points within this slide for us.
Yeah. And so what I wanted to do here is first look back at what Avinash talked about. So we talked about the dangers of, or the need for SSL pinning. And so SSL pinning binds a host to its certificate or public key. SSL pinning is a security mechanism used in mobile apps and web applications to enhance the security of the communication between the mobile app and the backend server. This is a protection level that is designed to prevent attackers from intercepting or tampering with the data exchange between the app and the server by verifying that the server's certificate matches an expected pre-configured certificate hosted at the server side. So what is an SSL pinning bypass attack? That is specifically an attack on a mobile app where an attacker is going to circumvent that security mechanism. And then with a modified app or anything else, the attacker can initiate connections to the server using their own certificate. They're replacing the certificate that was in the app with their own certificate, and they are forcing the server to accept that certificate. So since the app has been altered to trust the certificate, it is no longer checking whether the server certificate matches with the original PIN certificate or not. And that is what then allows the attacker to intercept and manipulate communications between the app and the server, but also launch additional attacks. So below what you see are my top 4 reasons for preventing SSL pinning bypass attacks. So the first one is around data integrity and privacy. The second one around trust and reputation. The third one around ensuring the security of user credentials. And then finally, preventing man-in-the-middle attacks. So Avinash, can you share with us your experience when you did your testing and analysis on an unprotected app and the differences that you saw when the app was protected by Appdome?
Right. So yeah, so when we tested this unprotected application, there were lots of things that can be done easily, like decompiling the application, exploring the source code, stuff like that. And then, what are if there is any basic protections implemented from the SSL pinning perspective or from the root detection perspective, it is possible to, identify those protections, try to bypass it through Freda and take an advantage of the application and their underlying functionalities or APIs and stuff like that. So when we use that binary added in the platform and ran the security model against them, when we got the compiled new version, secure version, it was very difficult, first of all, for us to read the source code of the application. That APK file was completely obfuscated. It was very difficult to understand what class is doing what's the logic is actually implemented and how the logic is implemented. So that was very difficult. And the good thing was also there that this particular, if you see, there's a highlight portion, right, that says insecure bank 2 detected a potential security threat. So if you see the reference here, maybe this reference could be helpful for an attacker to see where it actually relates back to the compiled binary, right? Maybe it's hard coded over there. So as an attacker, I tried checking these particular references in the application itself, but I couldn't find them. But why? Because they were also obfuscated. So
actually, Avinash, the references are specific codes that that explain the attack that happened. So if an end user would call the app maker and say, "Hey, the app is closing, it's not working," and then their support team can say, "Well, what is the reference code that is shown at the end of the message?" They give that reference code, and that then gives the support team the ability to quickly do a query in a tool that we have available to them that then explains to them what this attack was, what specifically is happening, but also gives some remediation steps for the user to take in order to continue using the app. So that's what the reference code is about.
Right. And from an attacker perspective, see, this is actually a reference for me to see where this string is available in the code. I mean, can I go over there, see what's the logic is implemented over there? And if there is a possibility for me to, see it to manipulate a particular logic. So, and when we tested this application, we couldn't find, because as it's available like as a 7215143. So this particular string was not available in the compiled binary. And it was obfuscated. Even though what I'm trying to say here is that even the string was obfuscated. So it's difficult for an attacker to actually go ahead and try to deobfuscate the code, first of all, or secondly, it's very complicated for them to, find the correct class, correct method to create a bypass logic for this application. So that's what the differences were when we tested an unprotected application, and then we tested application which is protected by Appdome. And also one really good thing which I liked about the platform is that I don't need to, if I have 10 possible fixes of mobile application, I don't need to implement all those 10 possible fixes, as by demand, as per my, workload, as per my time restrictions. I can only implement, bare minimum things if I have to from the platform, So for example, my demand said that, okay, I'm not actually thinking much about SSL pinning as of now. I only need to make sure that my code is obfuscated. So Appdome has that model, I can just go there, only check for code obfuscation and create a compiled binary, just as a quick fix. And later on, when we have that sort of resourcing available, then we can use all those other protection as well as a layer defenses, so that, it's difficult for an attacker to circumvent them. Yeah.
And I think that's another key thing to pull out of this, which is, like any defense technology, this is another layer in the onion ring. It never replaces fully and excuses the opportunity to engineer correctly when time is there. But this is now allowing us space to be able to mitigate risks by breathing time and achieve that balance between, as you said, Jan, business demands, technical resource availability, and so on and so forth. So absolutely fascinating here. Jan, just a few words from you on this, please.
Yeah, thank you. Again, Avinash, thank you very much for testing an Appdome protected app and validating that an Appdome protected app can indeed protect against all types of SSL pinning bypass attacks. Thank you also for showing that with an Appdome protected app, you are also protected against Frida and Magisk and other modern tools that are the favorites of attackers to try to break into an app and then do their thing. So Appdome is the one-stop shop for mobile app defense. So on Appdome, you can create a security model in a matter of minutes, simple point-and-click UI, and implement that security, build that security model into the mobile app. No code of coding required. There is no change to the way the developers have to work. In fact, the security team can be fully in control of the security model. The security team has full visibility, management, and control over the security model, can connect into the DevOps workflows by connecting Appdome to any CI/CD tool, and therefore implementing the right security model as a normal process and a normal step within the CI/CD and the DevOps workflow. Appdome also provides both security and dev teams with an artifact of proof, a certified secure certificate that demonstrates that the protections are indeed in the app. And so after you've done a pen test and you validated it with the pen test that everything is fine, as long as you don't change that security model, you don't have to do another pen test again, unless it might be required by a regulator or an internal regulation, because that certified certificate is the artifact of proof, is the security system of record for all of your protections. And on the top right, what you see is Appdome's mobile XDR solution. And why is that important? Because it's great to know that the protections are indeed in the app, but you do also need to be able to see if the protections are actively effective in production. You need to be able to know that the protections in the app are indeed stopping all the attacks in production, and you need to be able to know that what other attacks and threats may be leveled against your app. And then finally, Appdome also has a UI framework that allows you to better create better user experiences when the bad things happen. So that's a quick overview of us. Thank you.
I think this has been an absolutely fascinating challenge. It's lovely when any technology or product ends up our way and we are set a pretty tough challenge and then collaborate on all of the ways in which we could possibly begin to break it and be very open as a team and dialogue around this. And I've personally enjoyed watching this unfold. Avinash, to see you lead the team and sort of break some intellectual cycles against this is always fascinating. And
100%.
I think it's been a really, really interesting focus on one very specific use case, but one very, very important use case. So thank you, everyone. I think we'll leave it there. We're hitting around about 45, 50 minutes. We'll keep that tight there. So I'd like to thank Jan Sysmans from Appdome. Thank you very, very much indeed. Avinash, as always, love hearing your thoughts around how you pull things apart, and the team do as well. And what a very interesting session we've had today. Thank you both very much.